Gentlemen and ungentlemen, thank you for joining me again. Someone was bitching that I didn't do drunk videos anymore, so asking ye shall receive, gentlemen. Here's the S40, the tall boy. But I realized that this Chinesium boy that you guys are used to seeing in this in these lovely videos doesn't go high enough on the DC scale to measure some of these plate voltages in these things. It may be close to the edge on the receiver, but definitely for the transmitter it doesn't go high enough. It's got like 1500 volts on the plate. So in order to solve that problem, we have this beautiful thing here. This is a Heathkit IM-11 vacuum tube voltmeter, and it plugs into the holes in the wall that electricity comes out of, and then does things like measure voltage and resistification. So these old meters, the vacuum tube voltmeter, were special back in the day. Not special like me, but legitimately special. Because, voltmeters back in that day always loaded down the circuit, and as you recall, when you load down a circuit, the circuit changes, so you're not getting an accurate measurement. But vacuum tubes are very, 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 very high impedance devices, several tens of mega ohms. And so they made these vacuum tube voltmeters so that you could adjust sensitive circuits without loading down the circuit and fucking your measurements up. A modern digital multimeter is probably better than one of these, but not as cool. And if this channel means anything, that is style over substance, right? So here it is. So these things also take a C-sized battery for the ohms scale. And it didn't look like it leaked too bad, but I've got this variable voltage linear regulator module that I got off of the eBay that I think we can tap onto the filament supply for the tubes in this thing. Yes, that's why it's called a vacuum tube voltmeter. It has two vacuum tubes within it. But I think we can tap the filament supply with this bad boy and get 1.5 volts out of it to power the battery thingaroo, and then not have to fuck around with that anymore. So let me clean off the bench and we'll take this bad boy apart and see what is inside. Actually, I already know what's inside because I took it apart to make sure that the battery hadn't destroyed the whole thing, and I'd have to return it to the eBay guy. It's not pretty, but I don't think it's broken. So anyway, we'll see. The IM-11 came with its own probes. These are the special, not special like me, but genuinely special IM-11 probes right here. And, or probe, I should say. Singular probe. Where is my grabdificator? Or my snipterator? I never cut the zipper-rooter off of there. There we go. So, the probe is interesting for several reasons. A, it attaches with a fucking quarter-inch phono jack. That's not the way things are done these days, but it was done like that back in the day pretty often. It has an alligator clip for the ground. And it has a unscrewable snapperator on the positive probe that eventually comes off, revealing this lovely pointy thing that can be poked at stuff. But one of the interesting thing is you can switch it between AC/ohms and DC out here on the end of the probe with this little flippy switch. And what that does is there's a resistor inside of the probe body, and I think I'm quoting this from memory, so I'm probably full of shit, but I think when you put it into DC mode, it puts like a 1 meg or a 10 meg or some high value resistor in series with the probe, which is, I think, what allows it to actually measure like 1500 volts DC, right? So that must act as part of a voltage divider with the other internally deuteruder inside of the meter, right? So that's all fine and good, right? But what if the probe fucks up? What if I want to use like other more modern perish the thought probes? What shall I do then? Well, when we get this bad boy going, I have an idea. Yes, I know that's dangerous coming from me, but let's talk about this idea. See, I would like to be able to use at times my oscilloscope grabberators on this thing, which all use BNC connectors. So I think in order to fill this big hole, if we take out this 1/4 inch phono jack and put, banana plugs on this thing instead of a 1/4 inch plug, we could replace it with a BNC connector, and it would look happy and delicious, right? And then I shall do the unthinkable to a piece of vintage electronics. I shall drill a hole right there, and I shall mount a banana jack for a negative probe of the normal, more modern variety, and then over here I will drill not one but two holes and mount banana jacks of the modern variety, one of which will be for AC/ohms and will connect directly to whatever we have here inside, and the other one will have its own high value resistor in series, the same as the probe, so that I can use more regular probes, right? The problem, the only difficulty that I see with that is, what is the voltage? What is the voltage rating on probes, on the leads, the insulation for probes like this? It does not say. It does not say. Oh, wait. On the end of the probe it says 600 volts, category 2. So, I don't know, if we try to put 1500 volts through a probe like this, it's liable to surprise us in some way or another if the insulation is not rated to such a high standard. So this linear regulator module, I bought it off of the eBay. It was advertised explicitly as a battery eliminator for these, and had I known that it was simply an LM317 module, I would have made my own on the perf board. C'est la vie. Anyway, let's open it and see what sorts of treasures. Let's open it and see what sort of treasures are contained within. Nothing like a tasty beer, and probably like, I don't know, after it's rectified, maybe, 200 volts B plus or something like that. It'll be fine. Alright, let's look at this beautiful thing. Here's where the battery was. As you can see, there's a bit of schnong there, but we shall remove this Bluter-Rooter thing that sounds like a mouth harp, and to replace it with the other deuterator. And that tube is sideways for some reason. That's worrisome. I haven't tried to power this thing up at all yet. I don't know what to expect. Let's remove this corroded bastard altogether while we're here. That's got some stuff on it, doesn't it? Oh well, we don't need you anymore since we have our LM317 module. Mr. Beefy, this is not a place for you to be with high voltages. Doing high voltage things, I'm telling you, bud. It's not a good place for a kitty cat. So I guess we ought to put this back on here so that ground wire remains connected. Although I guess it doesn't really. Well, yeah, we better. It's probably just to make a better connection to the negative battery terminal, but just in case, we may have to take it right back off and hook it to that rectifier module. I actually have directions for that, although I'm sure we could have probably figured it out on our own. It's more fun sometimes to figure out things on your own, but sometimes when you figure out things on your own, magic smoke comes out before you figure them out. That always makes me sad inside. I don't like it. So let's look at this thing. It's got a pretty transformer here. It's got a old ass capacitor that we probably ought to replace. Oh, we should definitely replace since it's freewheeling here. What is that? 16 microfarad. 150 volts. Let me see if I've got one that high. I may not. 16 microfarads. Yes. As long as it's close, it ought to be fine. Alright, so this capacitor, this 150 microfarad, 16 microfarad, 150 volt capacitor, that's a power supply filter capacitor, and I don't have anything remotely that low of value with that high of voltage rating, but I do have these 200 volt 47 microfarad capacitors, and since it's a power supply capacitor and not part of some tuned circuit or something like that, I don't think that the value is critical as long as it doesn't draw too much current out of the transformer as the capacitor charges. I think it'll probably be fine. I hope. I don't want to blow the transformer up. I mean, I guess the thing cost like beer money for the most part, but I'd still kind of hate to blow it up, you know what I mean? That would make me sad inside. Alright, let's see, what else do we have here that's interesting? A couple of vacuum tubes. What kind of tubes do we have here? Let's pull them out and examinify them. Mini tubes. Here's a 12AU7. Very, very common dual triode, I think. You see the AX7 in a lot of audio amplifiers. I think the AU7 is the higher frequency version of it, but I wouldn't swear to it. I have a couple of old 1950s church organs that have one of these tubes for every key, so I should have plenty of those on hand for the time being. And what do we have over here? A short boy that almost fell out of the socket during shipping. That would have been not good. An EB91, a 6A15. I don't know what that is. Maybe it's a small rectifier? I don't know. No, this thing's new enough that it would have silicon rectifiers in it. Yeah, there's a rectifier diode right there. I don't know what that is. I shall read the GASP manual and find out one of these days. Alright, so we've got a wafer switch here for AC, DC, and ohms. Hopefully it's fine. I'll spray some contact cleaner into that when the time comes. Now this big boy here, this is the range switch, and it has a whole shitload of precision resistors all over it. And I'm wondering how much those resistors have drifted over the last many years. I guess this thing's probably from the 70s. I'm not sure when they made these. Let's see if we can test that thing in circuit. Hopefully there's nothing else in parallel with it fucking us up. So this one here says 900K. Let's see what it measures. 908K. That's close enough for government work. This one here says 90K. Can you see the meter? Let me put it over there where you can see it a little better. 90.1? By God. So this one's probably 9, but it's turned the wrong way. But if we've got a thing going on here, 9.02. By God. maybe it'll just work. Maybe I don't need to do anything to it. I mean, other than that big fat shit-ass capacitor right there. So is that going to reach the holes in the PC board? I think it is. Very good. Now we've got to desolder the bastard. It's funny how new capacitors are so much smaller than old capacitors, isn't it? That's really something. Long as we don't melt that meter movement, we'll be fine. There we go. Man, that thing came out hard. Hope I didn't fuck anything up. Now, we must be very careful of the meter movement. Come out of there, you little fuck. There we go. Now, is that not the jankiest shit that you have seen in the past 5 minutes? I thought so. Negatory side. Away from the meter movement, mister. Right through the hole. Like a good boy. There you go. That's not going to touch the back of the meter movement, so I'm not even going to trim the damn lead. I'm just going to leave the son of a bitch like it is. Oh, don't come out, you little twerp. That's good enough for government work. I guess we probably ought to actually make sure that it, like, works and stuff, right? Before we get too ambitious here. I'm going to try it. There are high voltages inside of here. Let's make sure that there's nothing untoward close by. Alright, that ought to be good. I have the 5-volt line of a bench supply plugged into the front end here, and I'm going to set this on 15 volts. And I'm going to set this on DC plus. The variac is on 0 volts. The variac is turned on. The variac is outputting approximately 30 volts according to my marks there. That tube is sideways. That tube socket may need replaced. That tube got loose already. Alright. 30 volts. I see no deflection on the meter. The pilot light is glowing very dimly. The pilot light is glowing brighter. I see no filament on the tubes. We are at approximately 80 volts on the variac. I am seeing deflection on the meter. The meter is reading. The meter is slowly rising. The meter is reading 4 volts. I'm turning the variac up. The variac is now set to 110 volts. Pay no attention to the actual legend on the variac. It wasn't correct. I had to remark it. The meter is now reading 4.15 volts. The variable voltage power supply is supplying 5.09 volts. Obviously, there is a certain amount of calibration to be done here. I've turned off the power supply. The voltage is dropping slowly as the power supply discharges. The needle is now resting on approximately 1 volt. I'm adjusting the zero adjustment to bring the needle back to 0 volts, and I'm turning the power supply back on. The power supply has risen back up to 4 volts. We've got some funny business going on. It's basically working, but I suspect that some of those precision resistors must have drifted. Let me see. Hey, look, we've got a filament there in this smaller tube. Let me see if I can set this where you can see it without electrocuting myself or someone else. So, down here on the 5 volt scale, I was reading the wrong scale before because I'm a dumb son of a bitch. Down here on the 5 volt scale, it's reading 4.1 volts. We switch it to the 15 volt scale, it's reading 4 volts. We switch it to the 50 volt scale, it's reading 4 volts. So it's reading about 1.1 volts low all the time. And the zero adjust is fine. So, oh well, if it's only reading 1 volt off, even at the highest scales, see there we're on the 500 volt scale, and it's reading 5 volts on the 500 volt scale as far as I can tell. I mean, obviously that's not very precision, but if it's only 1 volt off across the board, that's not something to worry about when we're measuring, you know, like 1500 volt plate voltages. So that's the Heathkit IM-11. It's getting late, and I fucked with this more than I was planning to, so we'll put that voltage, that 1.5 volt voltage regulator in there tomorrow. I have shit to do tonight. Alright, thanks for joining me. Talk to you later.